Hello, good evening. This is Mr. Batron, and today's lesson, the complex number system. What is a complex number? A complex number is a set of numbers written in the form of a plus bi, where a and b are real numbers, and I equals the square root of -1. Now, again, this is written in the form of a plus bi, where a is your real part and b is the imaginary part. Okay? What that means is if b equals 0, we call the complex number, the whole thing, we call it wholly real. And that's only because 0 times I is going to give you 0, so you're just left with the real part. Conversely, if A equals 0, then we call this complex number wholly imaginary. That's because when A is 0, we're just left with BI here. When we write a complex number or imaginary numbers, we want to write it in the form of a plus bi. So here's an example, a couple examples. Name the real and the imaginary part of the following complex numbers. For the first one, we have 4 plus 2i. So you can put a box around the 4 in red, and in green, we're going to put a box around the 2i. All right, so if we want to name this, that means A equals 4, and our BI, or our imaginary part, is 2i. Same thing here. We have -23, and then we have -6i. So again, if we want to name this, A equals -23, which is our real part, and our imaginary part, BI, is -6i. Right. Even with fractions, you still want to put a box around the -2/7, and then we're going to put a green box over the +4/5. So that way we're naming this A equals -2/7, and BI equals 4/5i. And last but not least, you have 2 minus 4i over 3. To begin this one, let's break it up. We're going to break it into 2/3 minus 4/3i. Now we're ready to name the real part and name the imaginary part. So the real part is A, which equals 2/3, and the imaginary part is BI, which equals -4/3i. Okay. Make sure that when you're writing this, remember, complex numbers are written in the form of A, your real part, plus or minus BI, your imaginary part. All right. So within the complex number system, we also have a complex axis, or the complex plane. Okay. In your real number system, on the left-hand side over here, we talked about the x and y axis here for you. And within the x and y axis, when you start at the origin, if you go left or right on the x, you have the set of real numbers. So you have the negative numbers on the left, and you have the positive numbers on the right. And if we're going up or down, you have the negative numbers as you go down, and the positive numbers as you go up, with the x and y axis on the coordinate plane. Now, as we're crossing over into the complex plane, the complex plane doesn't really have an x or y axis. It has the real versus imaginary axis. Okay, so on your real axis, you have your real numbers. So again, you have your negatives going to your left, and your positives going to the right. But on the imaginary axis, when you go up on the imaginary axis, that's positive I, and when you go down on the imaginary axis, that's negative I. The real axis, again, is A. and the imaginary axis is your BI, which has your complex number. Okay. All right. Let's move on. Also, we have what is called the imaginary circle, and this can be written two ways. So I wrote it both ways for you. You have the imaginary circle right here on the left side, and then you have basically we're going to transfer what we know in the imaginary circle on the left side, and we're going to transfer it over here to the right side of this diagram here. So when you start off at 0 degrees, okay, when you start off at 0 degrees, you go straight over here. That's just a line at 0 degrees. All right, it doesn't form an angle. So we say that I to the power of 0 is 1. And this may seem a little trivial. However, when you remember raising numbers to an exponent, when anything that you raise to the power of 0, that's always going to be 1. It doesn't matter if it's 2 to the power of 0, well, that's 1. You have 4 to the power of 0, that's 1. X to the power of 0, that's 1. Anything that we raise to the power of 0, x plus 1 to the power of 0, that's going to be 1 also. It's always going to give you 1. Okay? Now, we'll remember from rotations that when we rotate 90 degrees, and because 90 is positive, we go in a counterclockwise direction. So we're going to go from I to the power of 0, or 1, into the counterclockwise direction. So now our next stop is I. And that's also our first stop, so that's I to the power of 1. I to the power of 1 is I. Okay? We're going to take another 90-degree rotation. And our next stop is -1. So that's our second stop there. So that's I squared. I to the power of 2. All right, let's make another stop. Let's get around this circle here. From -1, we're going to -I. So that's your third stop. And that's I to the power of 3. All right, and let's complete the circle. Go around here. Well, this is our last stop, and this is our fourth stop, which also happens to be our first stop, which is I to the power of 4. So this is what we call a cyclic or a roundabout rotation, a circular rotation that just repeats itself. There are only 4 unique values that we get when we talk about the i's. All right? When we have I to the power of 0, that's 1. When we go around from I to the power of 0, we have I to the power of 1, that's I. I squared, or I to the power of 2, that's -1. I to the power of 3 is -I. And then we get back to I to the power of 4, which is where we started, and that's still 1 again. Okay? All right. I also created this table here, or this chart here for you. That way, if the circle is confusing, if you remember this pattern, this works out as well. The key thing to remember in red is that the definition of imaginary unit is when I equals the square root of -1. This is the second time that you're seeing this, so it's very important that it stands out to you. Okay? So again, I to the power of 0 is 1. All right? I to the power of 1 is I. I squared is -1. Well, how did that be? Well, first and foremost, I itself is the square root of -1. But if we take that and square it, when you square something that's being square rooted, it just gives you the answer that's under the square root symbol, which is -1. Okay? Here, we have I to the power of 3. That equals -I. Okay? I to the power of 3 can be written using your law of exponents as I squared times I. And by breaking it down, we know that I squared is -1. So you're multiplying -1 times I, which is just -I. It's the same thing. That's why that works. Okay. Here are a couple examples down here. We talk about I to the power 6. Okay. You can feel free to use this circle and go around it until you get to the I to the power 6. So I would start here, I to the power 0 first. So if I go here, let's go around. So let's get a highlighter. All right. So we have I to the power 0. Let's go I to the power 1. That's I. I to the power of 2. That's -1. I to the power 3 is -I. I to the power 4 is 1. I to the power 5 is I. I to the power 6 is -1. So we expect that I to the power of 6 to be -1. We can do the same thing again with I to the power 13. Okay, we start at 0 again and we work our way around. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I to the power of 13 is I. Now we have I to the power of 95. Okay? If you think that I'm going to go around this circle 95 times, it's not possible. I'm not going to do that. All right? So it has to be an easier way. If you remember from earlier, we said that there are 4 unique patterns, or 4 unique values, that are circled throughout this pattern. So if there are 4 unique values that are circled throughout the pattern, well, let's take 95 and divide by 4 and see how many times can 4 go into 95 evenly. So I'm going to take 95 and I'm going to divide that by 4. It seems that 4 goes into 9 2 times, because 4 times 2 is 8. 9 minus 8 is 1. 4 goes into 15 3 times. All right, because 4 times 3 is 12, and 15 minus 12 is 3. So I have 3/4 left over. All right, this is very important. Not the whole number, but the remainder is going to help us. Okay? So if we go around this circle 23 times, when we start over fresh at 92, we're going to go to 93, 94, and then 95. Well, that just happens to be I to the power of 3. And according to our earlier suspicions, I to the power of 3 is -I. Therefore, I to the power of 95 is -I also. All right. If that went too fast, we can continue to work with this on our earlier examples. For instance, I to the power of 6, if I take 6 and divide that by 4, I know 4 goes into 6 one time, and I'm left with 2 as your remainder. So we're going to now look at I to the power of 2. And we said earlier that I to the power of 2 is -1. So it works out. Same thing here, I to the power of 13. Well, we're going to take 13 and divide that by 4. And we said that 4 goes into 13 3 times. Okay, because 4 times 3 is 12, and we have 1 left over. We're going to take that 1, and that's going to be I to the power of 1. And I to the power of 1, as we said earlier, is just I. So it checks out. The only way you're going to get this is if you practice. Practice makes perfect. And I promise you, tons and tons of practice with this, you're going to get much better. Let's go and see what we have for practice. All right. Well, we have independent practice here, odd numbers, to which we worked on during class. Okay. we're going to use the strategies and the skills that we worked on during class, as well as some strategies from Math 1 to help us out with being successful with this topic. So let's start on number 1. Okay, that says I to the power 30. So what do you think we should do? Are you going to go around your imaginary circle 30 times to find a value? Or you think there must be an easier way? Now, if you think there has to be an easier way, then you're right. So let's use it. Let's take this 30 and divide by 4. How many times can 30 go into 4 evenly? Okay, well, there's 7, because 7 times 4 is 28, and I have how much left over? 2. Okay, that 2 is going to come in handy because that's what we need for our I. So we have I to the power of 2. Well, what's I to the power of 2? Now, if you don't remember that, if you at least remember that I equals the square root of -1, you can help use that to your advantage because now you have the square root of -1 squared. Okay? And if you need to square it, go ahead and square it. That way it works out for you. Okay? So anything being square rooted, if you're squaring something that's already being square rooted, you just get the answer that's under it. So our answer is -1. Okay? We're going to skip down to number 3. Number 3 has 3 times I to the power of 7. Well, we're really concerned about the I to the power of 7 and not really the 3. So let's go ahead and work with that and then bring the 3 in later. All right, so I to the power of 7. All right, that's more than 4, so we need to know what's our remainder. So if you take 7 and divide it by 4, you have 4 can go into 7 one whole time, and you have a remainder of 3. Well, what's I to the power of 3? Okay. You know that I squared from just doing it times I is going to give you I to the power of 3. Well, the value of I squared from just doing it was -1. So what's -1 times I? That's -I. So I to the power of 7 is equal to -I. Let's substitute now that we have that. So you have 3 times -I, which equals -3I. Okay. Number 5, okay, you can't add terms that are unlike. As we can see, you have an I here, but you have I to the 3rd power there. You can't add those together. So we have to find out a way of, I guess, simplifying them before we operate with them. So we know I is just going to be I. But we just talked about I to the power of 3. And according to our information before this sheet, or before this page, we said I to the power of 3 was equal to -I. So what's I minus I? 0. Therefore, I plus I cubed is 0. Okay? Question number 7. Question number 7, you have 3I to the power of 4 plus 5I to the power of 6. Again, you can't just add those. You have to make sure that they have like terms in order to just add them together. So let's try to clean up these i's here. Let's work with the 3I to the power of 4. Okay? We know that I to the power of 4 is the same thing as I to the power of 0. Or if you took 4 and divided by 4, you just get 1 with no remainder. No remainder. So I to the power of 0 is just 1. Okay? Plus 5I to the power of 6. We just did that a problem ago, but just for memory, let's go ahead and take 6 and divide it by 4. And that gives us 1 whole time, but we have 2 left over. Okay? So we need to figure out, instead of I to the power of 6, we need to find out what I squared is. And we said that earlier to be -1. So let's go ahead and substitute. We're going to substitute 3 times what we said to be I to the power 4 is 1, plus 5 times negative 1. 3 times 1 is 3. 5 times negative 1 is negative 5. 3 minus 5 is negative 2. Okay. Working on number 9. Number 9, you could do one of two ways. I would urge you to pull out your good friend, the law of exponents here, because we're multiplying two exponents with the same base. So when you're multiplying two exponents with the same base, the law of exponents says to keep the base and add the exponent. So 102 minus 98, or plus negative 98, same thing. By doing that, it helps you simplify your issues here, because you know 102 minus 98 is going to be 4. So we're left with I to the power of 4. And I to the power of 4 is 1. Okay. We did do the warm-up, we did do the even problems for warm-up, and I urge you to go back through those and work through those as well, just to make sure you're practicing.